I'm going to go through a couple of quick examples to remind you of how to use angle and segment relationships with circles. The first thing that you always want to consider is, how do I know when I need to use an angle relationship as opposed to a segment relationship for a problem with circles? And I would say the easiest way to decide which one you're doing is by looking at the numbers that are given, and anytime you see degrees, like we do here, that's how you automatically know this is going to be an angle problem, not a segment problem. After you've decided what kind of problem it is, then you need to know what relationship you're going to use. And remember, for angles, here's the relationships, and you decide which one of these to use based on what type of angle you see. Is the vertex at the center? Is the vertex on the edge of the circle? Is it just floating somewhere on the inside, or is it completely on the outside? So in this example, we see that the vertex of this angle is on the outside. And so that tells us that we're going to be using the relationship of angle equals 1/2 big arc minus little arc. And then from here, remember that you look at the picture and you decide where to plug in the pieces of information that you have. In this case, the angle is definitely the thing that we don't know. It's the question mark. So that means this would be x, and we would say it's equal to 1/2. Oops. In this case, the big arc is the one that they gave us. Again, big because it's literally bigger. And so 257 would go right here. And then I know they didn't label the little arc for us. That's this one right here. Even though they didn't label it for us, we can easily find what that is, because if this is 257, this little arc is literally everything else. So you can do 360, which is a total circle, minus 257 to get that this little arc right here is 103. After you've plugged everything into the relationship or the formula where it goes, then remember your goal is always to get x by itself. In this case, x is already by itself, so all I need to do is type this into the calculator to get my answer. And so I do 1/2 parentheses 257 minus 103, and I get an answer of x equals 77 degrees. So that's my answer. Now here's another example. Again, I might be tempted to say that this is another exterior angle problem, but again, look at the numbers. This is not given in degrees. I would have to see degrees on some of these numbers in order for it to be an angled problem. So I'm going to say this is segments. Now again, I got to remember the relationships for segments, and that's these right here. Again, depending on what type of problem it is, based on what it looks like, I would use one of these relationships. I think this one right here is the one that we're going to want on this problem. And so I start by saying outside times whole equals outside times whole. And then again, I plug in the pieces from the picture. When it says outside, that could be either 8 or 7. I'll go with the 8 first. So 8 is this outside, and I need to multiply it by the whole. Remember, whole, you have to add the pieces to get the whole. In this case, that means 8 plus 6, which I could write it as 8 plus 6, but I can also say I know 8 plus 6 is 14. Set it equal to the other outside is 7. And so I multiply 7 times. Again, in this case, to find the whole, I'm going to need to add these pieces. I can't actually add 7 and x, but I can write it at least as 7 plus x. Now again, from here, remember, you're going to want to solve for x, get x by itself. First of all, I can figure out what 8 times 14 is. That gives me 112. Over here, I can distribute this 7, meaning multiply it. And so I get that it equals 49 plus 7x. Then to get x by itself, I subtract 49 from both sides. 112 minus 49 gives me 63. And then the last step would be to divide by 7. And so I'd get my answer of x equals 9.